This FRQ question is from 2017 AP Physics 1, and now circuits are taken out of AP Physics 1 and they're covered in AP Physics 2 only. So in this problem, they say in the three circuits shown above, the batteries are all identical and the light bulbs are all identical. In circuit 1, a single light bulb is connected to the battery. In circuit 2 and 3, two light bulbs are connected to the battery in different ways as shown. The light bulbs are labeled A through E. Rank the magnitudes of the potential difference across light bulbs A, B, C, D, and E from largest to smallest. If any light bulbs have the same potential difference across them, state that exactly. So they ask you to do the ranking and they briefly explain how you determined your ranking. And on AP exam, if you do the ranking, just ranking itself will not give you the point. You have to do the explanation. So they understand that the ranking was done without explanation. That means the student does not understand what he was doing. He might have been just guessing. Every time I do my FRQs in the videos, go ahead and pause and try to solve the problem yourself, because that's how you learn, by making mistakes, if you make mistakes. And then you can watch my solutions and explanations. I read through each circuit. Before I start answering my questions, I'm gonna look at the problem or at the three circuits, and I'm gonna analyze them first. So here is your A, B, C, D, and E. They all have the same battery and they all have the same resistance or the same bulbs connected. So because I'm going to place these points right here. This one is going to be point A and point B. And the voltage on AB is called terminal voltage. And then it's the voltage outside of the battery. So here is going to be my AB. And here is going to be my A and B. For the first one, the total resistance of the circuit is just R. For the second one, the total resistance is 2R. They're connected in series. And for the last one, the total resistance is, this one I have to do calculations. For the parallel connection, there is a formula for the total resistance, and it is 1 over the first R, in this case just R, plus 1 over the second R, and that is equal to 1 over R total. And then you calculate and find what total resistance is. In my classes, usually my students know the formula, but they try to use this saying that we made up many years ago. So it's 1 over the first resistance plus 1 over the second resistance. That gives me 2 over R. The result flip over. So it's 1 over 1 over, the result flip over. So the total resistance is R over 2. Now I'm going to use Ohm's law, which says V is equal to I times R, to find the current for each circuit. So the current in this circuit, and the current flows from positive to negative. So the longer side of the battery is positive, the shorter side of the battery is negative. So again, here is positive, negative, and the current is going this way, positive, negative, and the current is going to go this way. So if I'm looking for the current, it is the voltage divided by the resistance. And the potential difference for every circuit, so VAB for all of them, is going to be equal to EMF, because they didn't say that there is internal resistance inside of the battery. So that means if I measure the voltage outside of the battery, then it's the voltage that will be dropped on all of the resistors together. So the voltage between A and B, or potential difference, is equal to EMF for all of them. So if I'm looking for the current, it's going to be the voltage between A and B, or the voltage on the resistor R, A or R, is equal to the EMF over the resistance, the total resistance. The current for the second one is again the terminal voltage between A and B, which is EMF, divided by the total resistance, which is 2R. So in this case, I have the voltage divided by 2R. And then for the last one, it's EMF divided by 2, by R over 2, but when you divide by a fraction, it's the same as multiplying by its reciprocal. So that's going to be R, and 2 will go to the top, to the numerator. For the next part, I'm going to calculate the power supplied by the battery. So the power, and I'm going to say the total power supplied by the battery, and that is going to be the voltage between points A and B times the current through A and B. So there are a few formulas that not all of them are given to you on AP exam. So it's I times V, that's the power. And then if you use Ohm's law, V is equal to I times R. You can replace V with I times R, which gives you I squared R. Or you can replace I with V over R, and that gives you V squared over R. This formula is given on the AP exam, the rest of them not. So and the Ohm's law is given on the AP exam. So these formulas you would have to derive yourself. So if I'm calculating the power provided by the battery, I will use I times V. So the voltage between points A and B is the EMF. So it will be EMF times the current, and the current is EMF over R. So the power supplied by the battery and the power that is used by the bulb is equal to E squared over R. So it's the total power and the power taken by the bulb. So it's the same power in this case. For the next problem, if you want to calculate the total power, then you would take the current through the circuit times the terminal voltage, which is going to be EMF times EMF over 2R. So in this case, we have the total power is EMF squared over 2R. And that was the voltage times the current. But the power on each resistor would be the current squared times the resistance. So as we said, the power is equal to I times V, or I squared R, or V squared over R. So I'm going to use this part to calculate the power on resistors. And because both resistors are the same, they take the same amount of power, or they take 1/2 of the power from the one that is provided by the total power provided by the battery. So in this case, for I squared, I have EMF divided by 4R squared. That's going to be I squared times the resistance. So power can be equal to I squared times R. So one of the R's can be cancelled, and I have EMF squared over 4 times R. So that would be the power supplied to each resistor, or taken by each resistor. And then for the next problem, the total power taken away by the circuit is equal to, again, EMF times the current in the circuit. So you have EMF times the current, which gives you 2 EMF squared over R. And then if I wanted to calculate the power taken away by each resistor, then here I have to be a little bit careful, because the current, the one that I calculated earlier, is the current coming out of the battery. In this case, each resistor would have that same current, because there is no other way to get from this side of the battery to the other side of the battery. You have to pass through each resistor to get there. The same is for this case, for the first case. You have to travel through the only line we have to get from one side of the battery to the other side of the battery. But in this problem, on the third case, we have the current, it can split. It can go, some of it will go through one resistor, and the rest is going to go through the other resistor. Then they will connect at point B and continue going to the other side of the battery. So your current, the one that we calculated right there, has to split. Half of it will go this way and half will go this way. Half because they're equivalent resistors or equivalent bulbs. They are having the same resistance against the current. So the current can split evenly to get from one side to the other side of the battery. So in again, for calculating the power on the resistor, I have to take the voltage between AB, which is EMF, times the current through one of the resistors, because they are the same, they have the same current, but it's only half of the current that is leaving from the battery. So if I take 1/2 of the current that is leaving from the battery, then that is going to be 2 EMF divided by 2, and then again divided by R. So you have 2 EMF divided by R, and then I have to divide it by 2. So what's going to be left is only EMF divided by R, 1/2 of the current that is leaving from the battery. So in this case, I have EMF divided by EMF squared divided by R. Now, going back to the question, they said rank the magnitudes of the potential differences across the bulbs A, B, C, and D, and E, and the largest, from the largest to the smallest. So the voltage on A, let me write it right here. The voltage on A is the terminal voltage, and that is EMF. And the voltage on D and E is the same. So this one is the same on D and the same on E, because they're connected in parallel, so they all have the same potential difference between points A and B. But for the second circuit, the voltage on V is going to be the same as on voltage on C, because they are the same resistors. But every time when the current passes through a resistor, it has to drop some voltage, potential difference. And the voltage that it drops depends on the current times the resistance. Because both resistors are the same, then the voltage that is dropped on each has to be half of the one that is provided by the battery. So in this case, it's going to be EMF over 2, and in this case, it's going to be EMF over 2. So I have here EMF over 2. And when they say rank the magnitudes of the potential difference across the bulbs from the largest to the smallest. So we have A, the same as D, the same as E, and then B is the same as C, but smaller than A, D, and E. For the next question, they say that batteries all start with an identical amount of usable energy and are all connected to the light bulbs in the circuits at the same time. In which circuit will the battery run out of usable energy first? So the one that is providing the most power to the bulbs will run out of the energy first. And then from what we see right here, from the total power, the most power is provided in the third case. It's 2 EMF divided by R. So in this case, you have the power provided by the battery the most. So from all three circuits, circuit 3 will round out of the energy first. And circuit 2 will round out the energy last. So if you compare these three, the third one uses the most power, so that burns the most energy per second. And the least energy is going to be used by the second because it's EMF over 2. And the middle one is the first one. So the first one runs out of the energy is the third circuit where the connection is in parallel. The last one runs out of energy is the second. And that was all they had for this question. And I usually when I have the circuit problem in front of me, and I'm gonna attach the circuit lessons that I had for my students. So when I have my circuit problems, I never start answering my questions until I break my circuit into details, so I see every circuit what exactly is happening with the formulas, and only after that I can answer the questions. They're easy to answer, because when you have to do it at the same time when you answer the questions, it's a little bit more complicated. Do it right away when you get the circuits if they're different. Answer these questions: how much current is through each resistor? How much voltage is dropped on each resistor? What is the total resistance? What is the total power that is used? What is the power used by each resistor? And after you answer every single of those questions, then it's easier to answer the ones that they will be asking you. And that is all I had for my 2017 AP Physics 1 question. And again, now circuits are covered in AP Physics 2. So you should not be, I think, seeing AP Physics 1 questions with circuits in the future, unless the changes happen again. Well, thank you so much for watching. I hope you enjoyed, you learned, and they were useful. And I hope I see you in my other videos.